Hey, welcome. Patrick Fitzmaurice here from the Change Cultivators podcast. We are continuing our exploration of the 40 under 40 global change leaders. I hope you are following us on LinkedIn and you subscribe to the podcast on your favorite podcast platform. This group of 40 under 40 global change leaders is a fabulous group of leaders who are creating great impact in the world and leading great teams through times of disruption and change. And so it's ridiculously powerful to talk to them all, and I'm honored to be able to do it. Today's episode is with Kelsey Mayo. Kelsey is a unique creature. Kelsey is a scientist. She's an engineer. She has blazed some key trails in the world of medical science, building a team from 6 to over 150 in 6 years to build the biggest genetic database in the world. And now she's moved out to a passion area for her where she's digging deep into women's health and launching a medical product in that. That doesn't do justice to all the dimensions of Kelsey. So listen, enjoy, and hopefully you get some great nuggets from Kelsey Mayo. Kelsey Mayo, how are you today?
I'm doing really, really well, Patrick. Thanks for having me.
Oh my goodness. We are delighted to have you, and we are super delighted to let your voice be heard as part of our Change Cultivators 40 under 40 change leaders. Your background is super impressive. And just what you're doing and how you've done it, I think is going to really be of a benefit for our audience to hear some of the wisdom that you have to share.
Well, I am certainly excited to share what nuggets I have and hopefully inspire some more women to step into these type of roles.
Awesome. I love that. So you and I talked a little bit about precision medicine and what it is and how you built a team from 6 to 60, which is a pretty awesome thing for a change leader to do. Give us a little bit of background on what that is and what you learned in doing it.
Yeah, sure. So I guess I'll start with a little bit of background. My passion has always been problem solving. I was this nerd in school, and I say nerd is a very lovingly and proud sort of flag to wave. I have loved solving problems, but sort of began my career in engineering thinking this is great. I want to be a materials engineer because I don't have to make up my mind yet. Everything is a material. I can go build bridges or aircraft or go into medicine. And as I worked through my studies, I realized that I was just so passionate about medicine because of that human impact. So as a scientist or as an engineer, oftentimes you're doing work really late into the night, and it can feel thankless. And so to be able to draw that direct connection from the work that you're doing to the people you want to make an impact on was tremendously powerful for me. And so I found my way from Georgia Tech, which is where I did my undergrad, to precision medicine because I had an incredible mentor. And I was building these biosensors, and it was such cool work. And I thought, yeah, I want to do this. I want to do something in the world of medicine. And I started hearing this term called precision medicine. And this was years ago. I won't say how many years, even though I know we're doing the 40 under 40. And it was this paradigm shift that I've been grateful to be a part of, where we're going from one size fits all medicine to an approach of healthcare that really takes into account the individual. So how do we walk in and say, Patrick, you've come into the doctor today. How do we understand what your DNA, what your lifestyle, what your environment, what all these things together mean for your health? And not only how do we provide better treatments for you, but also how do we think about preventative medicine as well? What are the right preventative steps for you to take to make sure you are as healthy as you can be? And so sort of the next phase in my career when I went into graduate school was to design these advanced therapeutics. And it was in the world of precision medicine. And I was trying to figure out how to deliver gene-based therapies to the sites of the body that were really relevant in particular cancers. So as many of us know from a lot of cancer, so many of us, I think everybody that you talk to has impacted or been impacted by cancer in some way. We know that chemotherapies, therapeutics are getting better, but they're still pretty non-specific. Radiation, chemo, they attack our whole bodies. So I was sort of on a mission to help solve that problem. How do you go from attacking all fast-growing cells in the body to tracking just those cancer cells that we need to take care of? And it was fantastic, and I loved it. But the next kind of problem that I encountered was that I was doing great research and I was building what I would consider the sort of Ferrari of drug delivery systems. But I had this aha moment where I was like, the world just needs a Camry. Not everybody needs to have a Ferrari. And I don't actually think we can manufacture the thing that I am making in my research lab at scale. And that was a real issue for me. It was sort of this moment where I was like, what problems do I want to be solving? I want to make a difference in people's lives. This feels about 12 steps further removed than I really want to be focusing my career. And so I shifted into this other aspect of precision medicine because, all of that basic science is tremendously important, but I really feel like you can't have these incredible innovations be effective unless you have people tackling the pipeline that gets them from where they're being discovered to the patient's bedside. And that is a huge quagmire of issues, operations, still a basic science as well as translational science to really get these innovations to the hands of the patients that need them. And so that's actually where I shifted my career. Mm-hmm. So after I finished my graduate studies, I went into an organization within Vanderbilt University Medical Center that was focused on building this amazing platform for precision medicine that was gathering huge amounts of data on people's health from this amazing volunteer program called the All of Us Research Program, and building a platform that would accelerate the translation of innovations from that, again, that basic science step, that initial discovery to the patient's bedside. So we were really trying to tackle that problem. And that's kind of where you mentioned building that team up. I think that's the point in my career that I was first responsible for building up an organization and building up a team. And it was really to solve that translation problem.
Yeah, it's so cool that you use the word problem solving because, it's a passion point for mine in any business situation. I think people don't actually tackle it as like, wait, how do I frame up a problem that I can actually go solve? And so I love that. And your engineering mindset is just fascinating to me. And the way I would pose it to you to see how you react is, you say you take a very engineering scientific approach to decision making as an executive. Why do you think that serves a change leader so well? Like, why does that mental frame that you innately have and through your training and schooling, why does that engineering scientific approach method serve you well as a change leader as you took this executive role to move this organization and your current organization to a different spot?
So, I do characterize myself in my job as I love solving really hard, really meaningful problems. And I'm kind of weird for an engineer, I guess, because they don't always have to be technical problems. And this gets to your point, Patrick, about, bringing scientific decision-making and processes to other areas of business development and growing teams and organizations. And I think one of the strengths of that mindset is, step one is actually figuring out what the real problem is. And I think that's underestimated by a number of people, but that's critical in science. If you don't have a good description or grasp of what that core problem is, then how can you expect to find an effective solution? So I think, that's sort of step one. And then get the data that you need to try and drive, the best decision you can make. And, science is never truly black and white. There's definitely, even in the best assigned experiment, you just have to make the best decision or the best conclusion that you can based off of the information at hand. And in business and in team growth, I think I see it all the time. How do I get information through an objective frame, through an objective lens, to try and understand the best approach to solve this problem? Right. And that experimental design too, try it, measure it. Did it work? Did it not? If it didn't work, don't blindly go forward. Pause and think about it and then try something new. Nothing ever works all the time. So I think that sort of iterative, data-driven approach is critical.
And you said to me, related to this concept when we had a couple of prep conversations, is That approach strips out fear for you, right? Like that approach, you literally use those words. They're in quotes on my pad here. How does that help a leader, a change leader, remove the fear of driving to a new place for a team?
Great question. I'd forgotten I mentioned it with that exact phrase, but that resonates so well with me. I think when you are in an industry like mine and you're living on the bleeding edge, you're doing things that oftentimes people just haven't done before. And that can be scary. And so I think returning to the focus of here are the problems that we're trying to solve, and they're meaningful problems. And here's a reasonable approach. You know, if anybody asked me, why did you make this decision? And I can point and say, this is the information I used to make the decision. It sort of takes the superwoman out of the equation. It's like, I don't have to be, a superwoman all the time. I need to make reasonable, intelligent, informed decisions and be able to back that up with some data. And I think that in my scientific career, that's where you get to, like when you're getting your doctorate, it's not that you know everything, you are not all knowing, but you know a heck of a lot. And you know how to go get that answer and admit when you don't know the answer, but you know how to find it. And that's like a beautiful thing that really is empowering. It does strip the fear out.
It's such a great, insightful thought. You're making me flashback. I've taught training on business problem solving before. I've designed curriculums to do that. And one of the quotes that I often use is an Albert Einstein quote, who we might attribute to being a great problem solver. And, literally he was asked, if you had an hour to solve a problem, what would you do? And he said, I would spend the first 55 minutes thinking about it, framing it, getting my head around, and I'd use the last 5 to solve it because that's pretty much just math at that point. And I hear a lot of that in you. It's like, how do I find a space to go solve, and how do I frame up a problem, and then how do I use a scientific approach to go tackle it so that I'm not afraid of it?
Yes.
It's so smart. I love, so I want to take a quick sidebar because I want to give you a chance to talk about your current work because I think it's so important. And you're leading an organization that's tackling a big issue. And I think just tell our listeners a little bit about that because I think they need to understand that about you.
Oh, absolutely, Patrick. So, I am a scientist. I am an engineer. I am a leader. I'm also a woman and I'm a mother. I have 2 beautiful kids, and I'm a survivor of hemorrhage, not obstetric hemorrhage, but actually, I lost one of my ovaries between my 2 kids, and it was a terrifying experience. And it was also incredibly ironic. And the reason I say that is because a couple years prior, I was in the middle of my graduate studies, and I had dear friends, also female engineers, who we met for coffee one day. And we were like, man, if we could do anything, if we could solve any problem in the world, what would it be? And we kept coming back to women's health. Because the sad truth is that there has just been so little innovation or engineering, scientific, innovation breathed into that field. And I think women are tough, and we kind of have suffered in silence and just dealt with the status quo for far too long. And so we decided, if we could do anything, this is what we would want to do. We would want to use all of our resources, all of our trainings to find these problems that are going ignored and address them with science, with engineering, because there are solutions that exist to the problems that millions across the world are facing. And it's time that we looked into that. And so, that was a couple years. And then I was sitting in the hospital after this terrifying experience where I had been hemorrhaging for 5 hours and blaming it on cramps. But I was bleeding internally, had no idea. And then, 10 hours after that, I ended up going into an emergency surgery and luckily survived that. And I woke up and was just like, you know what? A couple years ago, we talked about postpartum hemorrhage, which is a leading cause of maternal death worldwide. And we think we figured out a way to fix that. And all I could think of is like, wow, women are feeling this every single day. The things that I also experienced and in a parallel, again, it wasn't I wasn't pregnant at the time that I suffered my hemorrhage, but it was just like this moment where I am meant to do this. We need to solve this problem. We are going to do everything we can. We know we have a solution that could really be effective here. Let's go try it. And so my colleague ran with it. She actually has her own research lab at Washington University where she's faculty. And she invented a device which is totally non-invasive. It's a wearable sort of, you can think Fitbit or Apple Watch type device that can detect hemorrhage at really early stages because it's preventable. That's the shocking thing. Leading cause of maternal mortality is entirely preventable or 90% preventable if you catch it early. But the reason we're not catching it early is because in the clinic here in the US and across the globe, it is most often diagnosed visually. That means that providers are kind of eyeballing whether or not they think that this patient has lost so much blood that they're really suffering a hemorrhage and trying to decide how to treat back off of this. And this is not a slight to obstetric providers. They're incredible and I have so much respect for them, but they need better tools and we've got one.
Right.
So that's what we're doing. We have a wearable device that obstetric providers can use to detect postpartum hemorrhage early enough that we can address the severe morbidity and mortality associated with this condition. So
it's so good. I mean, there's pieces of this, the scientific engineering approach, the purpose driven focus of that. As I'm listening, I'm feeling like I'm underemphasizing another key part about what I think I know about you from our prior conversation, which is really the leadership piece. And so let me focus on that. You said to me, another thing I think you said to me is you can have a great product, but you're kind of, you didn't say it this way, but you're kind of screwed if you have a mediocre team. Why you didn't use those words. So I'm not attributing that phraseology to you, but you kind of said something like that to me. How do people like as a leader, you drove a team from 6 to over 150 in 6 years. You've built a structure, an organization. Talk a little bit about the people part. Cause I could listen to this conversation and say, cool. So she's super smart. She, solves problems. She sits in a corner by herself and she does it and it's cool. No. I don't think that's what I picked up from our conversation. So riff on that a little bit for us, if you would.
Yeah, totally. I believe very deeply that an organization is its people, not its products. And, I feel like the most important thing that I can do is find creative, sharp, hardworking individuals, bring them together and help them be their absolute best. Help them create a living organization that can do the things that we need to do, that can get these innovations into the hands that need them. And I just, I feel like that's oftentimes people erroneously shift the idea and think everything is product. But the best thing you can do is give a good product to a great team. But even if you give a mediocre product to a great team, hopefully they would first tell you, hey, this is mediocre and here's how we would redesign it to make it better. Or let's throw it out the window and let's do this instead. I think you have to trust your team and you have to give them that respect and empower them to bring their best to the job too. Because like I said, no single person can do this. I cannot sit in a corner and do this all by myself. Right. I absolutely rely on a team of dedicated people who share this purpose, who share this vision for what we're trying to do. And that's what makes us tick.
It's so cool. I could talk to you all day. However, I can't because we just have to put a wrap on this. So I want to thank you again on behalf of our Change Cultivators team for being one of our 40 under 40 change leaders. And thanks for sharing some of your wisdom through the podcast with our listeners. It's a delightful conversation and so much power in the nuggets that you left us. So again, on behalf of us, thank you.
You're welcome, Patrick. Thank you for having me.